can do at home. We got out some fancy equipment, but you can do all of this at home. We are going to measure how much carbon dioxide gas is produced by an antacid tablet. In the reaction, we're going to calculate the number of moles of carbon dioxide gas formed. We're going to convert it to grams, and then we're going to compare it to the grams of active ingredient. The active ingredient in here is sodium bicarbonate or sodium hydrogen carbonate. We're going to do that using this reaction right here. We're going to take our antacid tablet, sodium bicarbonate, we're going to add water to it. It's going to produce sodium hydroxide plus carbonic acid, and then the carbonic acid is going to break down into water and carbon dioxide, and the carbon dioxide gas is what we're going to measure. Now you say, why on earth would you take an antacid tablet and produce sodium hydroxide in your stomach? You're not. Your stomach is this reaction. Your stomach has hydrochloric acid in it, and when you take the sodium hydrogen carbonate, combine it with hydrochloric acid, you produce salt plus water plus carbon dioxide gas, and you might burp, okay? So this is the reaction that happens in your stomach. This is the reaction we're gonna do today. Our goal is to calculate how many grams of carbon dioxide gas we produce and compare it back to the active ingredient in this product right here. And you can do all of that in your own house right now with some balloons and some antacid tablets. You ready?
Let's do some science.
Okay, right now I've got Brito with his great lungs blowing up the balloons to stretch them. That's enough. Stretch them out. And he's gonna do that for each of the balloons just to get them stretched out, because we're trying to measure the amount of volume that the CO2 fills the balloon with, but we don't want to have the CO2 to work so hard that our pressure readings are off. So we're stretching the balloons off so that we can just make the assumption that the pressure on the balloon is atmospheric pressure, and then the pressure exerted by the balloon is atmospheric pressure. Okay, Brito, so you're going to be my lab assistant today. We don't have to goggle up because all we have is antacid tablets and water. All right, so we have 3 balloons that you pre-stretched for us. Good job. Good job. And then in each balloon, in the pink balloon, we're going to put 1 tablet that we've already pre-crushed. In the green balloon, 2 tablets. And in the yellow balloon, 3 tablets.
And the crushing was easy. We just broke the tablet up inside the container.
And since you don't have graduated cylinders at home,
what if they do?
Use that. Well, if they do, I'm like really proud of them. We're going to use a tablespoon. A tablespoon is 15 mils of water. We have our water here ready. In every balloon, we're going to put...
Are we going to put the tablet first or the water first?
Let's put the tablet first because that takes a long time.
Let's do it.
All right.
So I think we should use a funnel. That's my opinion.
Use a funnel. Okay, so this is a pre-crushed tablet, and we're gonna... Oh, that was a good idea.
Huh.
I thought it would all get stuck in there. I told him it was a bad idea. Maybe I should listen to his ideas more. Okay, so we've got 1 tablet in there.
You're gonna put the water in?
We're going to put...
Okay, so when you pour the water in, I'm supposed to seal it and tie it.
Yes, and then we've got to start timing.
Do it like immediately.
Yes, and then we got to start timing.
So all you have to do is hit start. So
all right, are we ready?
Do it. So squeeze all the air out of the balloon.
Okay, and this is going to be exactly 15 mils.
Yes.
1 tablespoon, 15 mils.
I can hear it fizzing. I'm keeping it closed though. Don't worry. I'm a very...
There you go. Feel that.
Is it hot?
Cool. It's growing. I'm gonna leave that there. Let's keep going. Come on. Let's do this.
All right. Let's do this. Okay.
I think. Oh, you know what? We should do all the antacid and then the water because now it's wet.
I didn't want to.
Poor plan.
It's wet. It's gonna get stuck.
It's not gonna get stuck. Just do it. Okay, if you're doing this at home, don't add water. Do all the dry first, then go back and add water.
You live and you learn.
Okay, that's it. Okay, so now we're gonna add 15 mils.
Wait, did you put 2 into the green?
Yes.
Okay.
We put 2 in here.
And there's 3 in
the
here.
yellow.
Go for it.
Okay, so this is the yellow one.
Oh my goodness.
Let me get you a cup to stand it in.
It's on fire.
It's not really on fire.
Come on. This is the 3.
Okay. And then,
Set the.
let me just see what the timer's saying.
You're good.
Because
You're
we
good.
gotta take a reading.
Go. 30 seconds. Man. Error. There's always error in any experiment. The error was a little bit slopped out on that one.
All right, so here we go. 1 tablet, 2 tablets, 3 tablets. At 3 minutes, we're gonna measure the circumference of the red balloon.
Now, something you told me was that this is an endothermic reaction.
It's an endothermic reaction.
So the reaction consumes heat.
Yes, so the balloon should feel what then?
Cold, because
Cold.
it's a heat
Feel-
sink.
All right, so feel that balloon.
So I don't like to just feel balloons. I like to measure
Oh,
temperature.
there's no timer. Wait, we'll measure temperature in a minute. So
What are we
we're gonna
doing? What are we doing?
We're going to measure the circumference of the balloon because the balloon is closest to the shape of the sphere. We're going to go around the fattest part.
Like my belly?
Yep, like your belly. Then we're going to measure in inches and then convert
It is
to
what it is.
centimeters.
Where are we using inches?
Oh, it's exactly
11
11.
inches.
Exactly 11 inches.
All right.
You gotta make units, which is 11
Hey
inches.
Siri, set a timer for 3 minutes.
I want to put these tablets in here. Do I
All
get?
right, wait. We got to.
So we're gonna do.
In 1 minute, we've got to measure the circumference of
It
that.
won't take me a minute to put this in.
Okay.
Okay, so we gotta set this so you can see it. I'm so excited. So the temperature in our ambient water right now is 27.9 C. 28 C. 28 C. 27.9, 28. It's like right there. 1, 2. That's like plop, plop, fizz, fizz. Oh, what a relief it is. That's an old commercial.
That was good, Dad.
What's the temperature doing, Wash?
It's going down.
Going down.
27.6.
It's an endothermic reaction.
27.5. 27.4. That's pretty cool. How low should it go?
It will probably go about 3 degrees max.
Okay, can I ask a dumb question?
We first have to measure the circumference of that balloon.
I want to measure. You hold the balloon. Put the pink one back up there. Oh, we should probably just set it in a cup because then we're going to set it.
Fattest part of the balloon. Now, they're not true spheres, so that's where we're introducing some error. Okay?
Oh, that one's 13 inches, like exactly money 13 inches.
13 inches.
1, 3.
Okay?
Remember that time I was Rambo?
Yes.
I need this for my hair since we got the corona going on.
Okay. And then we can go ahead and measure this one now.
Okay, do it. Has it been 3 minutes?
Yes.
Hold on a second.
Fattest part of the balloon,
I got
right?
it. I got it. 15.25
15.25
inches.
Now our goal is to get the balloon at its largest.
That's actually
Point.
cold. Look, our temperature's down to 27.0.
What did it start at?
28. It's gone down a whole degree. Oh, I wanted to ask a question about the temperature thing. Okay, so when you put it in there, it's the effervescence, the bubbles coming up. Is it the bubbles in the water carrying the heat out of the water that makes it cold?
No, it's the chemical reaction. It's called the heat of dissolution, the heat of dissolving.
But it's negative heat. It's actually the coldness.
Okay, No, actually, we measure exothermic reactions and negatives and endothermic reactions and positives because heat
Okay.
went into the system and converted to chemical energy. But let's stick with this concept because that whole exo-endo thing can be, but I have a whole lab for that, so don't worry. Okay, let's measure
But
again.
the thing that I like is we actually measured. We didn't just say, oh, it feels cold. We quantified it.
Yes, because if we were boiled, we would have just said it feels cold. That actually looks smaller. We may have our largest circumference already.
What was it? I think it's oh no, it's actually 11 1/8. It's a little bit bigger.
All right.
And an eighth is like,
0.125, so 0.13. Okay. All right, let's measure our green.
excuse me, you're blocking me. I'm your assistant now.
What were you like as a 10th grade
I
boy?
was in trouble. I promise you that. 10th grade was the roughest year.
It's probably a good thing.
Jupiter High School was glad I moved beyond 13 1/4, 13.25. They were glad when I made it through 10th grade. Actually, 9th grade was the hardest year.
Why was it so hard?
Well, it was full of life events, but the hard thing academically was that I got to repeat 9th grade English in 10th grade.
Now, why did you have to repeat 9th grade English?
Because I wanted to make sure I understood English before I moved on. Hey, and I write a lot of scientific papers now. Ooh, we're 15 1/2.
15.5. So the goal here, folks, is we're trying to get our largest circumference reading.
So can I just say, if you're my high school English teacher from 9th grade or 10th grade and I gave you a hard time, just Google Scholar Donald Aubrey Arrington. I've written a lot of papers. I've recovered. I've recovered.
You overcame your adversity.
He overcame adversity, and he realized he actually liked to learn once you got to college, right?
Yeah. Because
Which
I
is
was
really
learning.
cool.
Because I was learning about fish.
Yep. All right, let's take one more reading from each
Has
of
it
these.
been 3 minutes?
I feel like the balloons are shrinking, so
You're
we're gonna
feeling
modify. We're gonna modify the procedure.
I like our cup balloon holders. They're
Yes.
like
Egg
eggs.
holder.
Yeah. And it's like Easter.
Yes.
Drop a comment below if you got to do an Easter egg hunt.
Okay, so folks, we got our data. We found out that adding antacid to water is an endothermic reaction. It cooled down an entire degree. These are our balloons, 1, 2, and 3. And
going. I'm
this
just
is the
trying to
data
time
we're
it
going to
there.
use. We're going to convert our inches to centimeters, but this is the data we're going to use. So this is the data we just got. Now you'll notice that this data here, the one I had circled in purple, is the data that we're going to use. That's the maximum circumference. Why are we using the maximum circumference? Well, that's when we had the maximum amount of carbon dioxide gas in our balloon. And remember, we are ultimately trying to measure the grams of carbon dioxide gas. So we're going to need to dredge up some geometry from our past to calculate the radius of the balloon and thus the volume of the balloon. First of all, circumference, if you can remember from your geometry days, equals 2 pi r. Now this value here in green is our circumference. So if we plug in our circumference value, we can calculate our r value because math's like that and it's wonderful. And then once we have our radius right here, we can find the volume of our sphere by plugging it into this formula, 4/3 pi r cubed. You also learned that at some point in geometry, so we just need to dredge that back up in our memories. So let's go ahead and do the calculations for the pink balloon, and then I'm going to leave you to do the calculations for circumference and volume for the green and yellow balloon. Okay, so here we go. The pink balloon had a circumference of 11.13 inches. We don't want inches. If we convert that to centimeters, we get 28.27 centimeters. And the conversion of that takes us all the way back to chapter 2, and I'm not going to rehash that right now. Then, this is now our circumference, so we're going to plug it into our circumference formula to find out the radius of that balloon, the radius of that sphere. So you go ahead and you write 28.27 equals 2 pi r. 2 pi is a value, so we can divide both sides by 2 pi to isolate the r. And when you plug this into your calculator, you can simply plug in this divided by parentheses 2 times the pi button. Hit the pi button, close the parentheses, and then hit equals. So you're going to type this into your calculator, 28.27 divided by parentheses 2, hit the pi button, close the parentheses, hit equals. Okay, I'm going to pause 5 seconds so you can do that. And when you calculate your R, you should get 4.50 centimeters. So what does that mean? That means the radius of my balloon, which is a sphere, so this is in 3D, although I'm drawing in 2D. My radius is 4.50. My circumference, or my distance all the way around, is 28.27. But because I'm dealing with gases, I want to know the volume of CO2 gas in that balloon. So now I'm going to use the second formula that I brought up. The balloon is closest to a sphere, so it's going to be 4/3 pi r cubed. So we're going to write volume equals 4/3 pi r cubed. Now we just calculated R, and we said that R is 4.50, so that's the value that's going to go in for R. So you're going to write down 4/3 times pi times 4.50 cubed. And we've been out of school a while, so I'm going to remind you how to plug this into your calculator. You're going to type in 4.50, hit the little caret button, and hit 3. So that's going to be 4.50 to the third. Then you're going to hit equals. Then you're going to hit times 1.333, that's 4/3. And then you're going to hit times pi and hit the pi button and then hit equals. Okay, I'm going to pause for 5 seconds. You pause the video and work this out. Okay, when you work this out, you should get 381.7 centimeters cubed. We're going to keep with 3 sig figs, so we're going to round that up to 382 centimeters cubed. Now remember, when we learned about conversions, we said that 1 centimeter cubed is equal to 1 milliliter. So you could also say that the volume of the gas took up 382 milliliters. Okay, so that's the volume of the pink balloon that had 1 tablet. So I'm going to write 1 tablet here. Now what I want you to do is I want you to go back through and I want you to calculate the circumference and the volume of the balloon with 2 tablets and then with 3. So I'll get you started with the 2 tablet balloon. In the 2 tablet balloon, we had a circumference of 13.25 inches. So that's the 2 tablet balloon. This is the green balloon. And we had a circumference of 13.25 inches. And if we use dimensional analysis to convert, we're going to get 33.66 centimeters. Now, your job is to do 2 things. Your first job is to take the circumference and plug it in and solve for R. And then once you get that R value, take it to 3 significant figures. Don't over round while you're in the middle of doing math, otherwise your answer will come out pretty watered down. Then when you solve for R, you're going to plug it into V equals 4/3 pi R cubed, and whatever you got for R, that's what you're going to plug in there. You're going to do that for the 2 tablet balloon, and then you're going to do it for the 3 tablet balloon. And the 3-tablet balloon was our yellow balloon. And once again, you're going to plug into the formula C equals 2 pi r. What was our C value for the yellow balloon? It was 15.5. Why are these values going up? Well, we had more and more carbon dioxide gas, so it makes sense that the volume of the balloon would be greater. So this is going to be 39.37 centimeters. So you're going to plug in 39.37 centimeters equals 2 pi r. Once again, you're going to solve for r. Once you solve for r, you're going to plug that r value right here. Okay, so your job is to go ahead and calculate the circumference of the green and yellow balloon, the radii of the green and yellow balloon, and then the volumes of the green and yellow balloon. Now remember, this was all one experiment. So if we got approximately 382 mils for the first balloon, we should get increasing values, but somewhere in this realm of numbers. So if you get a really crazy number, you've done something wrong. So you go ahead and do that, and then we'll talk some more later.
All right, Chem Jen. So this is a balloon. We just put in these Equate brand antacid tablets, and it blew. There was no air, and
So it's like Alkaseltzer.
exactly.
That box was cheaper.
Exactly.
Walmart.
Anyways, so we physically, the chemical reaction blew up the balloon.
Yes.
And you were telling me that the reaction in the balloon is different than if I took it for my stomach.
Yes, because we added water into the balloon, but our stomach is hydrochloric acid. So we're not going to add hydrochloric acid into a balloon.
That might not go well.
No. So the reaction in your stomach is this one. Sodium bicarbonate plus hydrochloric acid
The dishwasher has spoken.
makes salt plus water plus carbon dioxide gas. So when you have this reaction in your stomach, you're making salt water in your stomach. You're neutralizing the acid, that's what's giving you indigestion, and you're producing salt water plus carbon dioxide gas. And then what happens often after you take an Alkaseltzer tablet? Or
Well,
you
that's my
immerse it in-
question.
What happens?
So this blew up. The end product in both of these is CO2 and CO2. So after I take an antacid, not that I ever do, but if I did take one and I had a massive belch, it would be the CO2,
Yes,
which would be like,
you would be belching CO2.